we have not started yet. So let's take a look at f of x equals the absolute value of x minus 2. And then g of x, which is the absolute value of x plus 3. Say it again. Is it okay? Okay. So now the question is, which function did I use to create f and g? There is a basic, simple function that I used to create f and g.
Absolute value of x.
Very good. It's the absolute value of x. So the base function is the absolute value of x, indeed. Now, how do I, there are two types of transformations. One that is on the x-axis, and the other one is on the y-axis. These are the both groups, basically. So how do I figure out which transformation this is? Is it on the x-axis? Is it a reference to x or a reference to y? Well, I look at the base function. If the base function is the same in both, inside both functions, it cannot be a change in x. Because I have the same thing, the absolute value of x. So this is if you want plus 0. So there is no need to put that, but I'm just explaining. So what this means, obviously, we are shifting this graph where? Right. So this is down 2. So it's a vertical, both are vertical shifts. One is down 2 and the other one is up 3. This is how you know whether it's a transformation on x or on y. Yes, you will be asked to graph the base function, which is the absolute value of x. Then you will graph the absolute value of x minus 2. Make sure that they are all parallel. So this is the absolute value of x minus 2. And up 3 will be this graph. 1, 2, 3. Make sure they are parallel to the original function. So this is the absolute value of x plus 3. And this completes the vertical shifts, either up or down. And the base function is identical to the previous step. You'll see in a minute when we look at combinations, though, what happens. So now let's look at f of x equals x plus 1 squared. And g of x equals x minus 2 squared. Now, what base function did I use to create f and g? So the base is?
X squared.
Yes, indeed, it's x squared. Very good. Thank you. So if it's x squared, now I need to identify whether this is a transformation in x or in y. Well, do I have identical x squared? No. I have an x plus 1 squared. And I have an x minus 2 squared. So obviously, the transformation is on x. Because inside function blah squared, I changed x into x plus 1, which shifts left and right. But now, which direction? So where will this function have its x-intercept? For which x value, I will find the x-intercept of this function. Right. So this is a shift to the correct. And this is a shift to the
Right.
Excellent. So both of them are horizontal shifts because I change x. Every time I change x, it must be a horizontal shift or something happening horizontally. So x plus 1, it's a shift to the right, to the left 1, because the x-intercept now will fall at -1. And x minus 2 will be right 2 because now the x-intercept will move to 2. Let's graph all three. We start with the base function. We remember the base function is x squared. This is our x squared. And then you perfectly said x plus 1 is a left shift of 1 because now the x-intercept is at -1, 0. And the other one moves to the right. So this is x minus 2, everything squared. Perfect. So these are horizontal and vertical shifts. Now the next group, reflections. So let's say I want to look at negative, the square root of x, and I want to look at the square root of x, the square root of negative x. And I know what you're thinking. I hope you're thinking, well, you cannot have a negative number under the square root. True. But then negative x being greater than or equal to 0 means that x has to be negative. That's fine. Negative x with negative in front is positive. Okay, so what is the base function that I used this time? I did use the square root of x. Awesome. But now, again, we identify which kind of transformation it is. That's the very first step. Is it on x? Am I changing x or am I changing y? Let's take a look at f of x. This is my function. Am I changing x? No, I'm changing the sign outside. So if this is the y value, this will be the negative y value. What type of reflection will that be? Positive y, negative y, or negative y, positive y, with respect to the, excellent. So this one is a reflection, WRT with respect to WRT, the x-axis. It's a reflection with respect to the x-axis. Let's look at the other one and we'll graph both. Now I analyze again. I look at this function, which is the base function, and then I look at this one. Well, obviously, the negative sign touches x. So this is not identical. This is the piece that is identical. But since this had plus in front, and this one has minus in front, this must be a transformation that involves x, right? It involves x, and it changes, versus this one that was a transformation that involved y, but this one it changes x from positive x to negative x, or from negative x to positive x. What type of reflection is this with respect to the y-axis? So this one is a reflection with respect to the y-axis. Very good. Let's graph all three functions. So here's the first, the base function. We remember the square of x. Please always remember the square of x. I thought it became our best friend. I still saw that many of you did not solve that problem correctly with finding the domain, although we had 3 problems in class. So I'm hoping that you're going to go back and review that. Okay, so the first one was a reflection with respect to the x-axis. So here it is. The positive graph from above the x-axis became a negative graph under the x-axis. Now the other one is a reflection with respect to the y-axis. So this is a square of negative x. Any questions? Yes, please.
How do you come up with the base?
Oh, from this list. Oh, how did I think of choosing that?
Yeah.
I just picked from the functions we talked about. And these are the functions. The functions I picked were from this list from last time.
Okay, so you.
From this, from x squared. I didn't pick x cubed yet. The absolute value, the square root we already looked at. I did not pick the cube root of x yet, and I did not pick the rational function yet. So it's a very good question, actually. If I don't know the base functions, transformations mean nothing. Good. Okay, other questions? Yes. Right.
If you had, this may be a really stupid question.
There is no so stupid question.
Well, I don't know about that. But if you had a function that was like negative square root of negative x, would that just flip over the order?
Very good question. So your question was graph f of x. I was going to use combinations right now. So why not start with this one? What was it?
Negative square root of negative x.
Awesome. So we want to we want to graph this function using transformations. Now, what I want to say about transformations is you're not supposed to find ordered pairs and graph the function perfectly. No, this is not what we're trying to do. We're trying to look at this and visualize the graph. So we learn here to visualize the graph, but not graph it using point next to point next to point next to point to make a perfect graph. No. This is an approximate shape, an approximate graph that will give us a better understanding of the function. Okay. So we want to graph this using transformations. It's a perfect example, so let's start. First, we have to identify, so here's the question. Graph this f of x, which is negative square root of negative x, using transformations. Meaning, I'm not interested in a perfect graph. I'm interested to see that we understood, we understand this graph and what it does and so on and so forth. First, I have to graph the base function. What is the base function used here? Very good. Then the first transformations must be in order of operations. Note, all transformations must be presented in the order of operations. All transformations must be presented in the order of transformations. Okay, so now wait a minute, what does that mean? If you give me this function and you ask me to evaluate it for -9, here's what I have to do first. I have to go inside the function, replace -9, x by -9, multiply by -1, and then when I'm done, and I take the square root, then I multiply by -1. So that's the correct order of operations. So in the order of operations, which transformation we apply first to this function? Exactly. Which is a reflection with respect to the y-axis. Reflect with respect to the y-axis. Now function 2 is a transformation on function 1. Transformation 2 is not a transformation on the base function. Transformation 2 is on function 1. So now I'm comparing not this, but I'm comparing this to identify what needs to be done. This is my function now. What transformation is this? Correct. Very good. So now this becomes negative the square root of negative x. Reflect with respect to the x-axis. Excellent. And this is the sequence. If you have questions, stop me. Deja, okay? Any questions? Anyone? Questions? Okay, so let's graph the base function first. Here it is. Then you told me to reflect it with respect to the y-axis. Excellent. So this is the square root of negative x. And then you told me to reflect the blue graph with respect to the x-axis, which is excellent. So that's why this is our f of x. This is the final graph. Before we look at the last group of transformations, I would like to use another combo function. Let's say f of x equals negative the cube root of x plus 2, and then minus 1. You can say, but this is a mess. No, you will see why not. And we will be able to picture this quickly. Which base function did I use this time? Yes. So indeed, the base function is the cube root of x. Remember, transformations have to be presented in the order of operations, as if you would evaluate this function for 5, and you work your way step by step to determine the function value at 5. So first transformation. I have the square root of the cube root of x, but now I have the cube root of x plus 2. Is this a transformation on x or on y? Yes. So this will be the cube root of x plus 2. If it's a transformation on y, it means that there is something going on left and right. So where does this go? Left 2. Very good. Transformation number 2 is a transformation on number 1. In order of operations, what would you do next? Exactly, multiply outside, which is a transformation on x or on y.
The x.
X does not change. It's the same x from before. Something else changes, which is outside and it doesn't touch x. So this must be a reflection with respect to the x-axis. Now transformation 3 is on transformation 2, on function from 2, which is this. Please identify what changes. Because if you say x changes, then we have to do something left and right. If you say y changes, then it's up and down. Is this a little blurry or is it me? Is it okay? Okay, so then what happens now?
It's going to shift up.
Exactly, because you're comparing these two. The transformation cannot be on x. It's completely outside of x. It doesn't touch x, so it's down 2. I'm sorry, down 1. Perfect. So let's graph everything. Bless you.
Thank you.
The base function. If you remember the graph, please remember the graph. This is the graph of the cube root of x. Then you told me to shift this graph where?
On the x-axis.
Very good, left 2. So this is the graph of the cube root of x plus 2. That's the blue graph. Then you told me to do what with the blue graph? Or to the blue graph? Reflect it. Very good. So this is negative the cube root of x plus 2. And then you told me to take the orange graph or yellow graph to move it where?
Down 1.
Down 1. So here it is. So this is the final graph, f of x. Yes, please.
You have to show all of them.
All of them. Yeah.
It's messy.
It's okay. Once you identify them, I will be able to read what you're doing. Once you identify them in the correct order, it will be fine. Okay, here's a question for you. Is this a perfect graph?
No.
Far from being perfect. Did I really show the exact x-intercept? I have no idea where it is. I haven't calculated anything. Do I know the exact y-intercept? No. But I can determine those because they're important points. And I should determine those. But other than that, the graph is far from being perfect, but it presents, it's a very good depiction of what the graph is all about. So since we're here, I would like us to find the x and y intercepts algebraically. So for this graph, find x and y intercepts. So let me refresh your memory. It was this. How do I find the x-intercepts for any graph? Yes. 4.
Like which the opposite derivative of course, like for x, you just put like
Okay, very good. So for the x-intercept, perfect. I have to find the zeros. Y equals 0. So negative the cube root of x plus 2 minus 1 equals 0. What type of equation is this? And how do I solve it? Yes.
You start by adding them, so.
Very good. Although he's keeping a secret from us, he didn't tell us what the equation is, but he will. Or someone will. Then? Right, so it's a radical equation. So we will have to cube both sides. Perfect. The left-hand side becomes very good. And the right-hand side is excellent. So then this is negative x minus 2 equals 0 equals 1, sorry, or negative x equals 3, or x equals perfect. So negative 3 comma 0 is the x-intercept. So obviously my graph, it's not too far from the truth. So it's right here at negative 3, 0. Not too far. Far from being perfect, but not too far from reality. Okay, so finally let's find the y-intercept. And Maeve already told us, she said, put x equals 0 in there. So f of 0 will be negative the cube root of 2 minus 1. And that needs to be approximated so I can put it in. But that's good enough for me. So this is 0 comma negative the cube root of 2 minus 1 is the ordered pair representing the y-intercept. Any questions for me? Any questions?
Could you please repeat those graphs that?
You mean this?
Yes. Yes.
What do you mean?
Like point 2 and 3, like how we graph these lines.
You mean 2 and 3 here?
Yes.
In order of operations. So if I'm given this function and I'm asked to evaluate for x equals 6, first I will change x into, or the inside into 6 plus 2, which will be 8. Then I will multiply by negative 1, which is the second transformation. And then I subtract 1, which is the third transformation. It's exactly how I would perform evaluating the function. So if I want to evaluate it for 6, first I have to do this, which is this transformation, left 2. Then I will multiply by negative 1, which is reflection with respect to the x-axis. And then I will subtract 1, which is down 1, which is a downshift of 1. This is the sequence of transformations. Just imagine that you're evaluating the function and do everything step by step in the same order. I will have more combos in a minute. Okay, allow me to finish the last two, stretching and shrinking. Okay, so let's suppose we have f of x, which is 2x to the third, and g of x, which is 1/2 x to the third. Of course, I'm going to ask you which base function I use this time. I'm trying to use as many as I can. And you will say the base function is? Very good. Then, if you remember, we identify if this is a transformation on x, if x changes, or if y changes. That's our next step. So, and I look. Does x change or does y change?
X change.
That's why I boxed it. Does x change? No, x does not change. It's the same x cubed. No change. What changes then is the number outside. The number outside means y changes. Y is x cubed. Now here y is 2x cubed. Now here y is 1/2 x cubed. So this is a transformation on y. So something happens this way. Okay. Now, if I graph x cubed, we have to remember this because this is an important odd function. So this is the graph of x cubed. Notice that at 0, it does not cross like this. We're going to learn about this in the next chapter. Okay? It crosses slowly. Of course, just one x-intercept, but slowly. So this is x cubed. Now, obviously, this is 1 x cubed. What do you think will happen to the y values if initially I had y and all of a sudden I multiply all y values by 2? It's a vertical, we call it vertical stretching of the graph by a factor of 2. So if this is height of 1, it will become a height of 2. If this is a height of -2, it will become a height of -4. So this is the new graph. Stretched vertically. So this is vertical stretching. By a factor of 2, this is 2x cubed. Now similarly, I know you already pictured this. What do you think will happen with 1/2? Yes, all y values will be divided by 2 this time. Bless you. So from the original graph, it will be opening up, and this will be 1/2 x cubed. So this is a vertical shrinking. We're shrinking the graph. We're pressuring. It's a pressure. We put pressure on the graph vertically, if you want. Okay. Last transformation. But maybe before that, let's look at another combo. Here's a combo for you. F of x equals -2, the absolute value of x minus 1 plus 4. Now we really have all transformations here that we studied so far. I would like you to give me the base function first. Awesome. Which we know a lot about. We know everything about. Now please, in order of operations, list the first transformation you will be applying to the absolute value of x in case you wanted to evaluate for, let's say, 5. You will have to do 5 minus 1 first. Then, this is 2 transformations now, careful. We multiply by 2, then we multiply by -1, and then we add 4. You can say, but I can multiply by -2. Correct. But when we decompose and find the transformations, we have to separate the 2 from the -1. Because there are 2 different transformations in there. So, first transformation, please. Yes, x minus 1, which is indeed right one. Second transformation, remember, is a transformation on function from 1. Yes, 2x minus 1. Is it a transformation on x or on y? Yes, which is stretching by a factor of 2. Very good. So, vertical stretching. Number 3 is a transformation on number 2. And now I have to put that minus in front. It's still a transformation on y. It's a reflection. Yes, how? Reflect with respect to the x's. And final transformation is on 3, on function from 3. And let me copy the function, and you tell me what changes. Upward. Do we understand the idea of transformations? Why do we have all this theory? It's because some of you, I hope, will be maybe statistical analysts, and you will collect data, and you will plot data, and you will come up and say, oh yeah, this is an absolute value such and such. Okay? Or a square root. Okay, so let's graph everything. So here is the absolute value of x. Then you told me to move it to the right one. So this is x minus 1. Then you told me to stretch it by a factor of 2. Okay, to the best of my knowledge, or my abilities, I'm gonna do this. So this is twice the absolute value of x minus 1. Then you told me to reflect this. Awesome. -2, the absolute value of x minus 1. And then you said shift this whole thing up 4. And in order to signify the difference or show you the difference, I'm going to just, you don't have to shade it in like that. I'm just want to make sure that this, you understand that's the final function. Okay, For this function, I would like to find the x and y intercepts algebraically, because we know how. So how do I find the x-intercept? Very good. Indeed, thank you. So this is -2, the absolute value of x minus 1 plus 4 equals 0. Can anyone identify the type of equation? We've discussed this. As you see, we can't leave anything behind. What type of equation is it?
Linear equation?
Thank you. It's an absolute value equation. Why? Because it has
Absolute value.
an absolute value in it. Very good. Stop torturing me. I know you know. Okay, what do I do next?
Subtract 4.
Very good. Next. Very good. By negative. Good. And now, indeed. What do I write?
X minus 1 equals 2.
Very good. The inside could be 2 or -2 for this to work. So then the first is x equals 3 and the second one is x equals -1. So 3 comma 0 and -1 comma 0. Let's see how far I was from the truth. I was. Not too far. Not too far, maybe, yeah, a little bit on the right. But these are the x-intercepts. So let's determine the y-intercept. What do I have to do? Perfect. So f of 0 will be -2, the absolute value of -1 plus 4. How much is the absolute value of -1?
1.
How much is 1 times -2?
-2.
How much is -2 plus 4? 2. So 0 comma 2, let's see how far I was. Oh, pretty good.
I have a question.
Yes.
How do you do the vertical stretching? So, except for
Like I did before with the example, what I did was, I said if this is 1, this should be 2. If this here is 2, this should be 4. I just multiplied the height here by 2, and I got that point.
guess.
No, I multiplied by 2. That's not a guess. That's not a guess.
She's like wondering how you chose which point on the x-axis to multiply by 2.
You can do that.
Any value, any point. For any, do it for several points. Very good. Perfect. Final transformation. I would like you to pay attention to this one. All the other ones were basically common sense. There was no real problem there. With the last one, it's very different. It's definitely the opposite of what you would expect. And why is this so important? For trig, where you get to trig functions. Okay? So here's the last one. I have a function f of x. I'm not telling you what it is. I don't have it. But I would like to graph f of twice x, and then I would like to graph f of 1/2 x. And the purpose of doing this is to identify horizontal stretching or shrinking. Obviously, it's a transformation on x, right? From having plain x, now all of a sudden I have twice x, or I have 1/2 x, right? So this must be a transformation on x. So this is horizontal stretching, shrinking. But which one is it? Which one is what? Okay, so let's talk for a moment about x cubed again. And can anyone give us this new function, f of twice x? What does it mean?
Stretch.
It will be?
Stretch.
No, I don't want you to say anything about that. I just want you to tell me how to write this function. F of x is x cubed. I want you to tell me what it is. What is f of twice x? 2x to the third power. Excellent. And then How much is 2 to the third? Okay, so now let's think about this. I know how to graph x cubed. I know that I replaced x by twice x. You would expect this to stretch the graph by a factor of 2, right? If I replace x, which is 5, by twice x, which is 10, you would expect this to happen, right? Careful. So forget about this. Now let's look at x cubed. Here's x cubed. So how would you graph? Forget about everything here. So all of a sudden we got 8x cubed. By replacing x by twice x, we got 8x cubed. How will I graph 8x cubed? This or this? Second one. What does this? What happens horizontally when I do that? So this is x cubed, 2x, everything cubed. So it's exactly the opposite. So this, it's a horizontal shrinking of the graph. Exactly the opposite that you would expect. Okay, let's discuss 1/2 x. What will happen now? 1/2 x cubed, which is 1/8x cubed. Let's analyze this one. You would expect that if I change x into 1/2 x, this would happen, right? A horizontal shrinking of the graph, right? I'm changing 10 into 5. So this should happen, right? Okay. Let's see what really happens. So here's x cubed. 1/8x cubed, is it this? Or from x cubed, 1/8x cubed is this? First one, right. So it's a horizontal shrinking, a horizontal stretching by a half factor of 2. So this is the opposite of what you would expect, horizontal stretching. Okay, and I would like to look at,
So,
yes?
so if I have it right, basically, whatever is happening, like stretching versus shrinking wise, whatever's happening to like vertically, the opposite is happening for horizontally.
Correct.
Okay.
Correct.
So, what are you talking
So vertically, we're not really lying if you want to say that. Vertically, when I multiply by 2 is a vertical stretching. When I multiply by 1/2 is a vertical shrinking. But horizontally, exactly opposite happens. So here it is. Here is page 246 from your text. I would like us to choose anything you like to discuss from 53 through 62. Okay, so let's look at 55. Good. So in 55, we are asked to create a function multiplying another one by 4. What transformation is this? Vertical stretching by a factor. We are not changing x. We're changing y. It's an outside change. So it's a vertical stretching by a factor of 4. What about this one, 59? Can anyone tell us anything about 59?
Horizontal stretching.
It's a horizontal stretch by a factor of 3. Horizontal stretch by a factor of 3. Very good. What about this one? 57.
Horizontal shrinking.
Horizontal shrinking by a factor of 1/5. Because we're changing x. Exactly. We're changing x into 5x. Exactly what we did here. When we changed x into twice x. This was a horizontal shrinking of the graph. Okay. Finally, I would like to look at any problem from here. And then I would like us to, I will give you some transformations and you come up with a function that has those transformations. Okay, so from here, is there anything that catches your eye? So, so you see these three, and these 3. For the following exercises, just describe how the formula is a transformation of, they call it toolkit, I call it base functions, it's up to you, it doesn't matter. Then sketch a graph of the transformation. Which one? Which one?
76.
Okay, 77?
76.
76. Okay, very good. So let's take a look at 76. And then I think we can put transformations to rest, I hope. Okay, 76. And this is on page 246. Oh, yes, I'm sorry. So this is q of x, 1/4 x to the third, and plus 1. Here we're asked to talk about it. Which base function did we use? Very good, indeed. The base is x cubed. Which first transformation we used on this function? It's 1/4 x, which is what kind of transformation? Horizontal stretching by a factor of 4. Horizontal stretching. Factor of 4. Perfect. Number 2 is 1/4 x to the third, of course, with a cube, plus 1. What do we do next? This is a transformation on number 1. It's a transformation outside of x. It does not touch x. As you see, there is no change in x from this to this. The change from this to this is outside. It's in y, so that's why it goes up 1. Agreed?
Yes.
Okay, perfect. So, yes?
Are we required to write the base function every single time?
Yes. Because if you don't identify the base function and you don't graph it, chances are not very bright that you're going to be able to graph the rest. Okay, so here's what x cubed. 1, 1, 1, 1. Okay, so that's all I'm going to, I just used 2 points. So this is x cubed. Then we know that we have to multiply all x values by 4. So this one, 1, 2, 3. 1, 2, 3, 4. 1, 2, 3, 4. And now you told me to move everything up 1. Okay, do you think we had enough of transformations?
No.
Please say yes, because I want to move on. Okay, but if you have other questions, of course. Our next section, yes? No?
Do we find the X and Y-intercepts?
If you want to, let's do it. So let's find the X-intercept. I have to set f of x equal to 0 to find the zeros of the function. 1/4 x to the third power plus 1 equals 0. 1 over 64 x cubed equals -1. Or x cubed equals -64. Yeah, so I moved this up here, but I should have moved this up here. So I have a minor error in there. My apologies. Thank you for asking for that. Because I have to correct my graph a little bit. Because as we see, we take the cube root. So x equals -4. 1, 2, 3, 4. Thank you. Thank you for asking. Good. So this is, as expected, a negative 4, 0. I went one too far. And now we want to find the y-intercept. The y-intercept is very easy because q of 0 is 1, which is right here. 0, 1. So the y-intercept, f of 0 is 1. Very good. Thank you. Thank you for asking that. Perfect. Any questions? Any questions? The next section is 3.6 absolute value functions. And you can say again, haven't we exhausted this absolute value? Well, apparently not. So we only want here to graph a few. So please choose. We really know everything about this. I just would like us to choose and graph a few, 1 or 2 absolute value functions. And then the other way. So please choose anything you want. We know how to handle this. It's not going to be any problem. So please choose any. We already know how to graph them using transformations. Which one? 31. This one? Very good. So this is x to the 4th. Where do I go? 4 units. What happens to 1/2? Correct. And then? Done. But this is not what we want to do because it says no transformations, right? It says for the following cases graph the given functions by hand. But we already know the graph, right? It was x, the absolute value of x, 4 to your right, to your left, I'm sorry, open up by 1/2, down 3. Right? Now we can visualize much better and we know these functions quite well. But in order to graph a function like this, so you selected problem 31, and this is from the text on page 252, and that function is 1/2 the absolute value of x plus 4 and minus 3. Perfect. Again, just a semester check. Let me tell you where we are, what we're doing. We finished this, we finished this. This was done a long time ago, so we're going to finish this, 3.6. And then we'll continue with inverse functions, and hopefully 4.2 modeling with linear functions. And this was done already. Okay. So here we are asked to graph this function. In order to graph the function, we have to simplify it fully without the absolute value first. So we start like before with those long expressions with 2 absolute values. We have to start with the absolute value of x plus 4. And we know that this, every time I see an absolute value, I know it to expect, if it's on an expression, not on a number. But if it's on an expression, I expect how many different situations? 2 situations. One which is x plus 4, another one which is negative x plus 4. If and if. If what? Excellent. And x plus 4 is less than 0. I refuse. Do not do that. I just want to make sure you understand you never need to solve the second one. So this becomes x plus 4 for x greater or equal to negative 4 and negative x minus 4 for s less than negative 4. And now I have the entire function, which becomes, of course, a piecewise defined function, which we know how to graph because we practiced that. Can anyone give us the 2 options here? So it's 1/2 and x plus 4 minus 3. 4x greater or equal to negative 4. And negative 1/2 x plus 4 minus 3 for x less than negative 4. Or finally, 1/2 x plus 2 minus 3, negative 1/2 x minus 2 minus 3. So we simplify the function fully without absolute value, and now we are ready to graph it. Can anyone give us the domain of this function? So this is -4 to infinity, and this is -infinity to -4. Can anyone give us the domain of this function? That's our first step. First question to ourselves. What is the domain? And the domain is? Of course. Indeed, -infinity to infinity. Which x values I have to have in the table? Mandatory. Very good, and also 0. See the symbols under -4, be very careful. A left parenthesis and the right bracket. Very carefully identify the corresponding functions for each subinterval. On the first subinterval, which function are we going to use? Yes, awesome. Be very careful here. And obviously 1/2 x minus 1. They're both linear functions. I need 2 points on the left and 2 points on the right. So -4 and -6 will work nicely. -6 times -1/2 is 3. And 3 minus 5, -2. Please plug in -4. -4 times -1/2 is 2. And 2 minus 5 is -3 inside the parenthesis. Now when you plug in -4 on the other side, you must get the same number. This function will never have a jump. So let's see, -4 divided by 2 is -2 minus 1, indeed -3. I plug in 0, I get -1, and I will also plug in 2 because I get 0. 2 over 2 is 1, 1 minus 1 is 0. I always look for the x and y intercepts, and you should too. Ready for this? From left to right, can anyone give us the first ordered pair? Very good. Next one. Bless you. -4. -4, -3. Open point. It will cross at what? At -10. So 6, 7, 8, 9, 10. So I'm also going to put -10, 0. But the other branch starts at the same point, 0, -1, and 2, 0. So I have to fill it in. And this is exactly what we expected. This was the absolute value of x, 4 to the right, vertical stretching. No, vertical shrinking, and down 4. We knew that before we even graphed it. So this is f of x, 1/2 x plus 4 minus 3. Any questions? So the transformations helped us in graphing this without even looking at any points. We knew what to expect because we learned transformations. Any questions for me? Any questions? Okay, so let's move on to the inverse functions and what they represent and et cetera, et cetera, et cetera. Okay,